All right, next set of notes, we're going to start talking about the 5 different special segments in a triangle. We're going to talk about the first 3 in these notes, your midsegments, altitudes, and medians. Your midsegment here is, this is going to be the first one, important highlight so we can see it. We're going to have a segment that's going to connect the midpoints of 2 sides of a triangle. So what does that look like? Well, let's draw a triangle here. We're going to draw a triangle kind of like this, okay? Or just whatever triangle you want. Whatever yours looks like, doesn't look like just like mine. But what we're going to do is we're going to go over here to the left side. I'm just going to eyeball where I think that midpoint might be. We need to make sure that we show it's a midpoint, that it's cut that side into 2 congruent parts by putting those congruent markings. Then I'm going to go over here to the right side, and I'm just going to eyeball if that looks good. I think that's where the midpoint might be. But we're going to show it's the midpoint again by putting congruent tick marks. But because they are not all congruent, we need to make sure we put 2 tick marks on this. When we connect these 2 midpoints, that segment right there, that's your midsegment. Mid, middle, just like midpoint, middle point, midsegment, middle segment. Every triangle has 3 midsegments, as you can see in this diagram right here. And the midsegments do not, okay, we'll highlight that, do not have a vertex as an endpoint. This will make more sense with some other special segments we have. What that means is where the angles are, the vertex, that's not where our midsegment is going to start or end. We don't come out of the vertex with the midsegment. It's going to go from midpoint to midpoint. So here we need to remember that all of these are going to be midpoints. So here's another midpoint. We'll do like what we did in our diagram above. And we do have another midpoint over here. So here we can see 3 midsegments, 1, 2, and 3. Now the midsegment theorem we're going to work a lot with here, and this is the big thing that we're going to be talking about with our with this unit with midsegment, is your midsegment theorem. You're going to, the midsegment of a triangle is parallel to the 3rd side. Okay, so we'll draw this out and work through this, and it is half the length of that 3rd side that is parallel to. So there's 2 different ways you can look at this, okay? If we're going to say that it's half the side, if we take this triangle right here, first we need to note that these are parallel. And if we're going to say that the midsegment ED right here, is half the length of the parallel side, or the 3rd side, AC, then we can say, okay, if AC is X, then ED is going to be half of X. And we'll use this formula as well as another one that we're going to draw in here to help us whenever we're trying to find the length of a midsegment or the length of the 3rd side. So let's go ahead and draw that same triangle, just kind of the best we can. It's okay if it's not perfectly the same. This is triangle ABC, and then we have that midsegment, okay, with endpoints E and D. So you can either take half of the long side to get to, or sorry, half of the 3rd side to get the midsegment, or if we say that the midsegment is X, you can just double or multiply by 2 midsegment to get that 3rd side. So remembering that multiplying by 1/2 and multiplying by 2 are opposites here. So multiplying by 1/2 is going to get us smaller to our midsegment. Multiplying by 2 is going to get us bigger to that 3rd parallel side. And let's mark these as parallel too. And again, it'll make more sense here in a minute, but let's go ahead and write something in right here. We're going to write in that your midsegment is always smaller to that parallel side. So here I'm going to put midsegment. I'm just going to put MDSG for midsegment is always smaller. Always smaller than the parallel side. So when you're going through and you're doing the math, you always need to make sure that midsegment number is smaller. So if you go and you find out you got a bigger number, you went the wrong direction. You need to take half. Or if you find out the 3rd side is, the parallel side's smaller, you need to go back and do the opposite. Okay, make sure you double. And again, we'll get some practice in here. So the first problem here we have in triangle MNL, WV is the midsegment. Well, we got a problem. We don't even have any letters. So here we're going to go ahead and label we know that the triangle's vertices are M, N, and L. So here we're going to do M, here's N, and here's L. WV is the midsegment, so that's going to be that segment in the middle of the triangle forming those two midpoints. So here we have W and V. We want to find the length of WV, so we want to find this. So we have to solve for X first, and then we have to go through and plug it back in. So what we need to remember here is WV, our midsegment, is going to be half of that third side, that parallel side. We're going to mark parallel again. Okay, so it's going to be half of ML. The reason is because the midsegment is smaller. To get smaller, you take half. If you multiply by 2, you're getting bigger. Okay, so we multiply by 1/2. So we can substitute in WV is X minus 4 equals 1/2 of, what's ML? 20. So we're going to take half of 20. So we go through and we do our math. Go ahead, I'm going to do it step by step. 1/2 of 20 is 10. Then I'm going to add that 4 to both sides so I can get X by itself. And X is going to be 14. Now, we can already tell what WV is going to be by taking, we know it's half of 20, so WV is going to be 10. So now we can check, plug in for X with our X minus 4 and see if we get that 10 that we're supposed to have. So we plug in that 14 and we find out that yes, WV, we did solve for X correctly because it should have been 10, half of that third parallel side. Okay, there's your midsegment. Now we're going to move on to altitude. When you think of altitude, you know, I asked the classes, what do you think of when you think of altitude? A lot of students say, oh, that trampoline park. I go, good. The trampoline park, you're jumping up, you're getting higher up. So you're talking about height. When you're cruising on an airplane, they're like, we've reached an altitude of 30,000 feet. That's how high up in the air, how tall, the height of it. Okay? So with altitude, the big thing we need to remember here is that this is going to be a segment that's going to come from a vertex. That's why we said the midsegment does not come from a vertex. This one does come from a vertex, always. That is perpendicular. Okay, we need to remember perpendicular is that 90 degrees. We have a hard time remembering that. Okay, it's perpendicular. It's that upside down T symbol. It's going to be perpendicular to the opposite side or line, we'll discuss that in a minute, containing the opposite side. So we talked about how sides and angles of a triangle are across from each other. So what we're going to do in this first thing is we're going to notice that the altitude is not always inside the triangle, okay? So we're going to draw the altitude from vertex 0. So we're going to start up here at vertex 0, and we're going to go straight down as perpendicular as we can, okay, as straight down as we can, and it's going to form a 90-degree angle. This 90-degree angle is going to be one of the most important things about altitude. Okay, we'll see that in a minute. Over here with this triangle, if we go straight down, we're going to notice the first one kind of looked like it was in the middle. This one definitely is not because the triangle's a little different. That O vertex is shifted over a little bit. Now, when it says the line containing the opposite side, what happens with this guy right here is if we go with altitude, we can't go inside the triangle because that's not going to be going straight down. We still have to go straight down. And what it means by line containing the side is if we extend this, that dashed line means it doesn't really exist, but it's there. Okay? We extend the side, and that's the line containing the opposite side. That's that line. And that's going to create that 90-degree angle right there. So you need to be aware there are several different ways you can see altitude on the triangle. Okay? Your altitudes always have a vertex as an endpoint. As I stated earlier, we're always going to come out of a vertex. The altitudes, we're going to talk about here, we have 3 altitudes, just like the midsegment. These 3 altitudes can intersect inside, outside, or on the triangle, okay? And this intersection where the 3 altitudes are going to intersect is what you call the orthocenter. The orthocenter you're going to need to know. This is going to be a point of concurrency, which means it's just going to be that point where all 3 of them are going to intersect. So again, this is where all 3 altitudes, okay, so we got 3 altitudes intersect. So when we look at this diagram here, we have 3 altitudes. Here's one right here going down to a 90-degree angle. We rotate right here. We've got another one right here going down to a 90-degree angle. Rotate here, another vertex going straight down to a 90-degree angle. That point of intersection right here, this point of concurrency, this is your orthocenter. You're going to want to remember somehow orthocenter goes with your altitude. Okay? So when we're working with altitude only, not talking about the orthocenter, this is what a problem is going to look like that you'll have. We're given that AF right here, segment AF is the altitude, so we know we're going to have some 90-degree angles here. There's going to be 90 degrees on both sides. We're going to find the value of x, so we're only finding x with altitude, that's what you'll do. If the measure of angle 1 is 8x plus 18, well, measure of angle 1 and the measure of angle 2 are always 90 degrees. So with altitude, you always want to remember 90 degrees. So whatever algebra they give you with altitude, you just set it equal to 90 degrees. And then we'll go through and we solve our problem. Solve for x. We're going to subtract that 18 from both sides. Bring down the 8x. 8x is going to equal 72. Divide both sides by that 8, practicing our algebra. X is going to give us 9, and we're done. Okay, so there's your big old altitude lesson. Height, orthocenter, when they all three intersect, set things equal to 90 degrees to solve for x. The last one is your median, right? When you think of a median, think about in the road, when you're driving down the road and you have that median in the middle, that's that concrete and grass, a lot of times they have trees and everything, it's in the middle. It's between, halfway between the the traffic going both directions. So this is going to be a segment from a vertex to the midpoint of the opposite side. Remembering the opposite side, the side is opposite of your vertex, okay? So when we sketch this, if we take and we just kind of go, okay, let's draw a triangle kind of like this. We have this triangle. We need to go from the vertex on one side to the vertex and then go to the opposite side. And again, like we did with midsegment, we'll just eyeball where that median might be. So we're going to go from the vertex down to that median. And how do we know that's, or down to the midpoint? How do we know it's the midpoint? Because we always make sure to mark those congruent markings. Okay? So some things to remember about your median. You're always going to have a vertex as one endpoint again. So this is where I said the midsegment will make sense. The median and the altitude always start at a vertex, or always have a point at a vertex. This time they are always going to intersect inside. Unlike altitude, when they all three intersect, they always intersect inside that triangle. Your point of concurrency, where all three intersect, is called your centroid. Okay, this is where three medians intersect. This centroid is going to act, what we're going to put here, it's going to be, the centroid, fill in centroid, acts as a balancing point, meaning if you take the centroid, the triangle, and you take the triangle and you hold it on the tip of the pen or pencil, it should stay balanced if that's truly the centroid. Okay? So here we have our centroid, but we need to make sure that we're aware that all three of these are medians by putting our tick marks. So right here, our first median right here, going straight from the top vertex, it's going to cut, this point right here is going to cut that side into two congruent parts. Rotate, we go from this vertex down to the median. I'll rotate this way. This midpoint right here is going to cut this side into two congruent parts. And if we rotate again, see how they're not going straight down like the altitude, okay? This is, we need to go to the midpoint. So we go to the midpoint here, and now we have another set of congruent markings there. And so again, these three on the outside, these are all of our midpoints. The one on the inside, this is our centroid. So centroid is going to be where the three medians intersect. So now remember that, median, centroid. All right? So let's take a look at the problem we have here. We've got a nice easy one without algebra. All right? Your median here, we have that segment BG is the median. So we know that right here, point G is a midpoint. So we have two congruent parts. We want to find CG, okay, right here, if AG is 62. Well, in this case, we have a median. That's that important word to remember. So, since we have a median, G, we're going to write all this stuff down, is the midpoint. Put MDPT, midpt. So, therefore, segment AG is congruent to segment CG because of that midpoint. And therefore, we're going to do another therefore, the length of AG, or the measurement, is going to be equal to the length or measurement of CG. Remember, when two segments are congruent, their measurements are equal. So in the long run here, AG, we found out was 62. We're going to substitute in, and that's going to be equal to CG. CG. So they're going to be congruent. If you have algebra, you just set them equal to each other like we always have with two things that are congruent. And there are your very quick notes on midsegment, medians, and altitudes.